Hi guys, so we're going to be going through this question. It says to find the transfer function for this system. So first we're going to be dealing with the mass M1. So we're going to be drawing a free body diagram. This is the mass M1. But the first thing you want to do is that you want to hold M2 to be stiff and move M1 in this direction, the direction that was given. So when you move it in this direction, it's going to be pulling on this spring and this damper, and then the damper will be trying to pull it back. So we're going to have two forces, Q1, X1, but I'm just going to convert it to the Laplace form. In the case of the spring, this is what I'll just write X1. Sorry, in this case, it'll be Y, actually, not X. There we go. Now, the second opposing force is the damper, of course. So it's going to be B, S, Y, S. You can see this is for a damper. If this is B, it's going to be B, S, X1, S. So it's possible one. Then the next thing we have is the applied force going this direction, so it should be F of S. And then the next thing we have is that the mass is also going to oppose itself. So mass opposes sorry, the mass is not going to oppose itself. The mass is going to oppose the direction. So it's going to go in this direction. M1, 1, Y1. Or in this case it should become S square Y1 S. Now this spring also plays as it's going in this downwards direction. It's pushing on this spring, which means the spring is trying to push back on it. So the spring is going to be like this K2 Y1 S. Now the next thing you want to do is that you want to hold this stiff. So you hold it so it doesn't move, and then you're moving M2. When you move M2 in the direction it's supposed to move, it's going to be dragging this K2 to come down with it, which means K2, the spring will be pulling on the mass. So in this case, for the second mass, or we can just write it, you're going to have K2, but in this case, the displacement is Y, so Y2 S. You have to write the equation, just get everybody that has Y1 S and group them, so it will become M1 S square plus BS plus, in this case, it will be K1 plus K2. It's just familiar to group them. All of them are under Y of S equals to, because sum of applied force is equals to sum of opposing forces. So everyone that's in this direction is in one force, the other one's in this force are the opposing forces. As simple as that. So Fs plus what else is the opposing force? K2 Y to S. Now you can just simply move this here. So if I move it to just become, so this is our first equation. Now just to simplify this, I'm going to make this A, and I'm going to make K2 specifically B. You understand why I did that soon. For the second equation, let's work with M2. So for M2, hold M1 and move M2. So when you move M2 downwards, it's going to be pulling on this spring, which means the spring will be trying to pull it back. You're going to have K2 Y2 S. The mass also opposes its motion, so M2 S square Y1 S, actually 2, sorry, not 1. And then when you hold M2 to be stiff and then you move M1 in its direction, it's going to be compressing the spring, which means it will be pushing on M2. So you can draw it here or you can just draw it here. Anyway, you have space. So here is going to be K2. The displacement in this case is Y1, so Y1 S. If you have to write out the equation, it's going to be K2 Y1 S is equal to opposing forces is M2 S squared plus K2 Y2 S. You can just take this to the other side to make it one and the same. Going to be minus k2y1s. Everything will not be equals to 0. Now again, I'm going to assign this to become c. So 0 equals to c y2s minus b y s. So that's one. I forgot. Now you can see this one. You can see in this formula we have y2s and fs, and that's exactly what we're looking for. So let's just find it to substitute y1s. So from this equation, make y1s subject formula. It's going to become c over b y2s. Substitute it inside there. It's going to become ac over b y2s. You substitute this into this minus b y2s. Since we are seeing two y2s, we can just factor it out. Equals to f of s. Now we can just make, you know, LCM. So this will be b equals to ac minus b square. This is y2s equals fs. Now you can simply just write y2 over fs, which is going to be equals to b over ac minus b square. I can simply just substitute back what a, b, and c are. So it's going to be just b, which is simply k square, all over. This will be your final answer. Thank you for listening. Hope you understood.